Hi, this is Dr. Matthew J. Traum from Engineer Inc. The purpose of this video is to showcase the next at-home laboratory prototype that I've completed for our Mechanical Engineering Fluid Mechanics online course. This is a miniaturized wind tunnel and pitot-static probe experiment that allows experimenters to use the pitot-static probe to measure wind velocity in a wind tunnel. The wind tunnel, which you see here, is just made out of a metallic tea can, and if we sneak over here we can see the pitot-static probe sticking into the wind tunnel, and the wind tunnel is created essentially using a computer fan. You see the face of the fan there, and there's some honeycomb that I put up in front of the fan to reduce the turbulence that's coming down out of the wind tunnel. If we sneak around the back, there's the computer fan, which is attached to the wind tunnel, and of course I've cut out a hole there so that the wind can blow through the wind tunnel. And you see the power cord running down to a voltage and current meter to tell me the power that the fan is consuming, and then I can control the speed of the fan with this dial there, and it connects to the wall, which is giving me 12 volt DC current to run the fan. The other component that we have is a little ambient weather station here that's giving me both the barometric pressure and ambient temperature and the relative humidity. So barometric pressure turns out to be an important parameter in wind tunnel experiments, so we have to have a way to keep track of that. If I zoom in here on the pitot-static probe, it's just mounted on a magnetic mount there, and some threaded rod is used to hold it in place along with a couple of nuts. And on the back of the pitot-static probe there is a total pressure port and a static pressure port, and you can see I've connected some silicone tubing to those ports. I am going to eventually use very clear Tygon, but all that I could find at the local hobby store at the moment was the silicone stuff. It's opaque but not transparent, so it does the job, but we'll replace that with something transparent that will do better when we take this thing out to the market. And you can see here in the silicone tube I've got my manometer fluid, which at the moment is just liquid water with some red food coloring in it. I'm also going to change the fluid to something that has a lower density, maybe alcohol, so that we can get more accuracy in our manometer measurement. But what is going to happen here is I'm going to turn on the fan, and we should detect a change in the height of the fluid on one side with respect to the other side, and that change in height along with the known density of liquid water is going to give us a pressure difference from the total pressure part of the pitot-static probe and the static pressure part of the pitot-static probe, and from that we should be able to back out the velocity that the probe is measuring. So right now the fan is off, and we should see that those two fluid levels are at exactly the same elevation since there's no velocity. So what I've done here is just set up a metallic ruler that's sitting level on my work table, and what I'll show you, zoom in on the ruler there, is if I come along and measure the height, whoops, try again, measure the heights of those two fluid columns, they should be the same since there's no velocity, which they are. And now I'm going to turn on the fan, and it's going to be very loud, so you're not going to be able to hear me. I'm not going to say anything, but I will take the same measurement, and you'll see that the fluid has different height in the different columns, and then I will shut off the fan so you can hear me again and conclude the video. So now I'm going to turn the fan on. And up. And we see the fan is pulling no more power, and you can hear that it's shut off. But as I had the fan running, you could see the different heights of those two legs of the column of fluid, and we would use that measurement then, that height difference, to determine the pressure difference across the pitot-static probe, and from the pressure difference across the pitot-static probe back out the velocity that the probe is measuring. So that's my prototype. Thank you for your attention, and look for more videos from Engineer Inc. on our take-home laboratories for our mechanical engineering fluid mechanics course. Thanks for your time.